In this lesson, we are going to apply absolute value function to deal with real-life situation. The question states, while playing the pool, you try to shoot the ball into the corner pocket. The ball is at point A and the pocket you are aiming is at point B. You are going to bank the ball at point C. Write equation for the path of the ball should you make the shot. There is a accompanying figure here which indicates the position of the ball, the position of the pocket, and the point where you are going to bank the ball. This is clearly a V-shaped graph indicating that it's an absolute value function graph. What is the general equation of absolute value function? General equation of the absolute value function is with respect to base function y is equal to mod of x. So y is equal to mod of x is in fact the base function, and if we want to write any equation which describes including all the transformations, that would be y is equal to a into x minus h plus k, where vertex is equal to hk and a is vertical stretch. So assuming that the original path or the absolute value function's graph is this. So if that is this graph, then we have the other side of this graph going through these corners, and if we continue on this side, so this is y is equal to mod of x. Obviously this is the point O with coordinates 0, 0. Now the new path of the graph of absolute value function is ACB, where clearly the vertex is at 6, 0. So here the vertex, given that vertex is HK is equal to 6, 0. So the equation of transformation, which was named as number 1 here, so the general equation of transformation, as described in equation 1, if we substitute the values of h and k, this equation of transformation will become like y is equal to a times x minus 6 plus 0. Still a is unknown. A is not known. And until we have the value of a, the equation for the path of this absolute value function or for the path of this ball is not known. For finding A, we only need one point on the path. We know that the point A with coordinates 5 and 5 by 4 lies on the path. That is for sure because we are given that the ball's current position is at point A. So if we substitute the values for x and y for 5 and 5 by 4, this gives us, so let's substitute the value of y, 5 by 4 equal to A into, instead of x we are going to write 5 minus 6 plus 0 is nothing anyways. So 5 by 4 equal to A into minus 1 modulus. The mod of minus 1 is equal to 1. Therefore, A is equal to 5 by 4. So substituting this value back in equation number 2, substituting value of A in equation 2, we have y is equal to 5 by 4 into x minus 6 as equation for the path of ball, So now this equation describes the path of ball. In order to answer the second question, which is that should you make the shot, if the point B lies on this path, like if the coordinates of the point B satisfy this equation, then you should make the shot, otherwise you should not. So if B with coordinates 10, 5 lies on the path, lies on this path for which the equation is, is y equal to 5 by 4 into x minus 6, then we should make the shot. Then you must make the shot. So let's check that. Substituting 10 for x and 5 for y, this means 5 equal to 5 by 4 into 10 minus 6 implies that 5 is equal to 5 by 4 times 4. 5 will get cancelled with 4 will get cancelled with 4, and 5 is equal to 5. It means that point B lies on the path, which means B lies on the path, and for sure you can make the shot. But there are other elements of this graph which we will need to discuss. And we already know that vertex is at point 6, 0. Axis of symmetry. Axis of symmetry. Those are always the x coordinate of the vertex equal to x. So axis of symmetry will be x equal to 6, because if you take a look on the graph here, this is going to be your axis of symmetry. So if the point C has coordinate 6, 0, then the equation for this line would be x equal to 6. So these are axes of symmetry. And if we want to find out the x-intercept is the point where graph intersects x-axis. So x-intercepts is the point where y is equal to 0. This means if you have equation of the path, then substitute y is equal to 0. This will give you 5 over 4 into x minus 6 mod, which means x minus 6 mod is equal to 0. This means x minus 6 equal to 0, which means x equal to 6. So six, 0 is the x-intercept. Which is again the same vertex. For y-intercept, always, doesn't matter whether that is absolute valued function or any other function. For y-intercept, x is always equal to 0. So if you substitute x equal to 0, then y would be equal to 5 by 4 into 0 minus 6. This means y is equal to 5 by 4 times 6, 2 and 2 3 times. So this is 15 over 2. This means the y-intercept is, so the y-intercept is 0.015 by 2. And for vertical stretch, the vertical stretch always can be found by comparing it with the general form. Here, given equation of the path, is y is equal to 5 by 4 into x minus 6, which suggests that a value is 5 by 4. We already calculated it. This implies a is equal to 5 by 4. We calculated it before. And this a value is, in fact, that tells us if it is vertical stretched. If the value of a is greater than 1, then it's vertically stretched, which clearly is. So the stretch factor, so the graph as compared to base graph, so the graph as compared to base graph is vertically stretched. And stretch factor is 5/4. We want to find if it is horizontally stretched. Horizontal stretch occurs when the value of A is between 0 and 1, which is clearly not the case. Reflection occurs when the value of A is negative, but because there is no reflection as A is positive, no reflection as compared to graph as compared to base graph, base function, and no horizontal stretch as well, and no horizontal stretch as compared to base function. So these are the properties or elements of the graph of absolute value function. And if you have any other question, post it in the comment section and we'll be happy to answer your questions.